Well, let's look at a typical quantum number problem where you're given these sets of quantum numbers. You have to write down whether it's valid and where the electron would be if it is valid, and for those that are invalid, give a reason. So what we're dealing with here is just looking at each of the numbers and seeing whether the values are allowed for the numbers that we have. So if we take a look at A first, we've got n equals 3, and if n equals 3, then L can equal 0, 1, or 2. And you can see already that L equals 3, so that's not going to work out so well. So L is outside the range. Or outside allowed range. And that's because L can only equal 0, 1, or 2. Alright, looking at the next one, this is B. We've got n equals 4. Whoops. N equals 4. That means L can equal 0, 1, 2, or 3. And you can see that L equals 3, so that looks to be good so far. Now M sub L can equal any value from negative L to plus L. Now since L equals 3, that means that M sub L can be negative 3, negative 2, negative 1, 0, 1, 2, or 3. And it is negative 1, so that seems to be okay. And M sub S is negative a half, and that looks to be okay as well. So what we have for part B is a valid set. The location would be, well, let's see, so n equals 4, L equals 3, and the code for 3 is going to be F. And if we have F, we've got a total of 7 possibilities. 7 orbitals, and we're looking at negative 3, negative 2, negative 1, 0, 1, 2, and 3. The location is M sub L equals negative 1, and the M sub S is negative a half, which is going to be an electron pointing down. So that's what that would look like. So that's for part B. Now for part C, we've got n equals 2. That means L can be 0 or 1, and we've got that, that's okay. So M sub L is going to be negative L to plus L, so it can be negative 1, 0, or 1, and M sub S equals negative a half. So that's okay as well. Alright, so that's a valid set, and the location would be 2, and 1, the code is P, and for P we've got 3 orbital sets, or 3 orbitals, and we're looking at negative 1, 0, and 1, and we're looking at M sub L equals 0, so that one, and M sub S is negative a half, so it points down. Alright, so we've got these two being valid. This next one, we've got n equals 4, and L values can be 0, 1, 2, and 3. And as you can see, the L value is negative 2, which means that that's going to be invalid. And the ranges for if n equals 4, then L can only equal 0, 1, 2, or 3. L can never be negative anyway, but that's definitely why this one is going to be invalid. Alright, so there you go.